In this video, we're going to discuss about piecewise defined function. Okay, a graph for piecewise defined function. So it means that if you see that what is meant by a piecewise defined function, there is a combination of many functions according to the different intervals, right? So it means different interval, they have its own defined function, which is for this one, x less than 0 is a quadratic function, and for 0 to 2 there is a linear function, and greater than 2 there is another function, right, which is x minus 2 power of 2, right? It's a quadratic function. So okay, let's look at how this graph drawn. So you see that x squared minus 3, right? So as you know that x squared, we go one by one, right? We go one by one. In your mind now, the basic here will be x squared minus 3. So x squared minus 3, the graph will be look like this way, right? So you have to go through all the graph for quadratic, square root, absolute value, reciprocals, linear function, everything. Only you come to piecewise defined function here. So you see that this is the graph for y equals to x squared minus 3, right? So we in our mind, this is in our mind, all right? In our mind, we know that there are three graphs, okay? X minus 1, so you know that it's a negative 1, so the graph will be passing through. It's a linear graph. And x minus 2, will be 2. If you're very familiar, this will be the graph for x minus 2 squared. So there are three graphs here, right? Three graphs here. But this piecewise function is defined for have different defined function for different interval. So we have to make this tree graph. We have to bring this tree graph into the draw it into an axis where there are different interval have different graph. All right. For example, I draw this graph and let you see x, y, and 0 here. Okay. So we're going to look at the first graph here. The first graph, because the first one is x squared minus 3 for x less than 0. So it means for x that less than 0, the function will be x squared minus 3. So then you know that minus 3. Suppose the graph to be x squared minus 3, right? But they said only for x less than 0. So I'm going to draw the graph. Go to this side. Right? X squared minus 3. We only draw half of the graph here, because of the x less than 0, which do not include the 0. Alright, so means the x equals 0 is do not include. It's an empty circle here. So we only draw this graph for this interval. Alright, x squared minus 3. So let's look at 0 to 2. Right, 0 to 2 means 1, 2. So there is another graph, right, which is 0 to 2, x minus 1, right? X minus 1. So means x minus from 0. We only want the part from 0 to 2. I'm going to erase this one. 0 to somewhere here, I don't know. So 0 to 2. So I'm going to, I want to know where is 2, right? This is a linear graph. I substitute 0, I have negative 1, right? I have negative 1. So means negative 1 here. I put an empty circle here, right? Empty circle here. And it's from 0 to 2. From 0 to 2, there is a linear graph here, right? Linear graph. So I need 2 points to draw a straight line. So I put 2 here. 2 minus 1. So your y value will be 2 minus 1, you have 1, right? 1. So during 2, it will be 1. So it will be 1. I put a dense circle, a solid circle, because what? There is an equal here, right? There is an equal here. So I draw, okay? So if for better, I can find the x-intercept, right? The x-intercept for the line y equals to x minus 1. So the x-intercept will be y equals to 0, right? Y 0. So x equals to 1. Yeah. So you sketch, this is the graph. I'm not going to draw everything because it's only for this interval from 0 to 2, right? Open circle, close circle. So this is the line they want during this interval. This is the straight line, right? Okay, after that, 2. 2. So during 2, so you know that, can you see that the graph here? X minus 2 square. So they only want when they greater than 2. So means that I'm going to erase this part here, the left side, because they only want 2 and beyond, right? 2 and beyond. So this one is an empty circle because why? There are no equal here. So here will be an empty circle here, and the graph for this will be going this way, right? Going this way. So this will be a piecewise function. Can you see that? Different interval have different type of graph, right? Different function here. So this will be the piecewise function graph. So how to read the domain from here, right? You have to be careful when you read the domain from the piecewise function. So you can look at the interval here, right? If they are joining. So if you look at this during 0, right? 0 is not included even for the first interval and the second interval here, right? It's not included. Can you see there are 2 empty circles here? So I'm going to write negative infinity because there is a graph here. Right? The quadratic graph is continue. So if we're up to 0 here, I'm going to break it 0 because 0 is not included for, right? 0 is not included. So, but 2, so during 2 is included, alright? Even though here is empty, but 2 is included in one of the function here. One of the function here is include the 2 here. So 2 is from 2, then up to infinity, from 0 up to infinity, right? So this one 2 also empty circle, so 0 is excluded. So for this one 2, right, the x equals to 2, but because of one of them is a solid circle, so I accept the 2. Alright, accept the 2 means I continue 0 and continue up to infinity, right? And how about range, right? The range, so the range will be, you look at the y-axis here, right? The graph start from minimum. Okay, we see if you move from, if you bring a ruler, you draw, the minimum will be -3, which is not include the -3 up to there is a graph here, right? This is the graph, right? They are continue. So up to here, -1, right? -1. Even though -1 is not included, but there is a graph here, right? There is a graph. So means there is a graph everywhere. So graph. So even though they break, but the graph is actually for any value of y that more than -3, there is a graph, right? There is a graph here. So everywhere there is a graph. So it's from -3 up to infinity, right? -3 up to infinity. So this is the graph for this function. So is this a one-to-one function? So let's say the question may ask you that, is this a one-to-one function? This is not a one-to-one function. If the question asking about, because why? If you draw a straight line, y equals to k, they will intersect at 2 points, right? So 2 points. So if you draw the line here also, they will intersect at 3 points. So means that the horizontal line test failed. So intersect more than 1 point. Therefore, this graph, this function is not a one-to-one function. Alright, so let's look at another example for piecewise function. So you can try first before you look at the solution. Alright, let's look at this example. They require to find the domain and range, right? Find the domain and range. Find the domain of f and range of f and sketch the graph, right? Sketch the graph. Sketch the graph of fx. Okay, in this video I'm going to mainly talk about how to read the domain and range from a piecewise defined function and sketch the graph of fx. Alright, so okay, as I tell you in the previous examples here, you're going to, in your mind, you're going to know about what is this type of graph here, right? What is this type of graph here? So the first graph here will be x plus 2. You know that x plus 2 will be intercept at 2, right? Intercept at 2, and they will be intercept the x-axis at, intercept x means y is 0, right? Y is 0, so means x plus 2 equals to 0, so we will have x equals to -2. So this is the graph for the first one, right? X plus 2 here. So okay, I do it one by one so that you understand. So I draw the axis here, y and x. So I'm going to do it part by part. So for x less than 1 here, so means that 1, alright, 1 less than 1. So it will be x plus 2, right? X plus 2. So you know before this you have -2 and 2, right? -2 and 2. So during 1, we need one more point here. So during 1, so because you want a straight line, you want to know the straight line is here. You don't want to know where they stop because 1, right? 1. So when you put 1 inside here, 1 plus 2 in your mind, 1 plus 2, you have 3, right? So it means at 3, during 1, it will be at 3, right? When you put 1 here, 1 plus 2 is 3, right? But cannot include 1. You just use the 1 to find the point here, right? So that you know how's the line go. So the line will intercept the negative 2 and y-intercept at 2 and go up to 3, which does not include the value of y equals to 3. Alright, x. So this will be the graph before 1. So for the graph between 1 and 4, this is a reciprocal graph, right? Reciprocal graph where if you can refer to the graph of reciprocal function in another video. So 2 over x, the graph will be looked like this way, right? In the first and the third quadrant here. So when 1, what happened, right? So you know that it won't be here, right? Because the 1 between 1 and 4, right? So it means it's only section of the graph, only part of the graph here. Means that only part of the graph, one will be equal and the other one will be empty circle here. So you see that it's between 1 and 4. So you know during 1, you have to substitute 1 here. You substitute 1 because you want to know what is the point here, right? So when x equals to 1, so y equals to 2 over x here. So it'll be 1, so you were getting 2, right? During 1, it will be 2. So this one included because why? There is an equal here. So then you know that there is a curve here, right? There is a curve here. If you see that this is a small curve here. Out of all the full curve here, so this is part of it only from 1 to 4. So what happened if 4, right? 4. So when x is 4, your y will be 2 over x, which is 2 over 4. 1 over 2, right? 1 over 2. So 1 over 2. So it means that here 1 over 2. 1 over 2. So during 1, 2, 3, 4, 2, 3, 4. During 4, it will be 1 over 2 here. So I put an empty circle because there are no equal here, right? So you know that the graph is supposed to be reciprocal, right? Yes, supposed to be this way. But there's only one part of it only, which is this part here. Which is this part. So it's from 1 up to 4. So now let's look at the third one. The square root function. So which is y equals to negative square root of x minus 4. So as you know, want to sketch the graph for square root function, you can refer back the video for square root function. So the first step will be you look at the domain. X minus 4 must be greater or equal 0. So x greater equal 4, right? So means the graph will be going to the right. But because of the negative here, it's going down. So you know that 4. So when you substitute 4 here, 4 minus 4 will be 0, right? So the graph will be somehow like this. Okay, it will be 4 starting at 4. Without the negative here, it's supposed to be the curve to be this way, the graph of square root. But with the negative here, it's going down, right? Going down. So means include the 4 and then going down, right? Going down. So this is the graph for this piecewise function. It's also not a one-to-one function. You see that if you draw a horizontal line, they cut at 2 points. It's not a one-to-one function. Okay, so I already sketched the graph. So how to read the domain and range, right? So the domain. If you see that there is a graph here, right? Anywhere there is a graph, there is a graph, there is a graph. For 0 also there is a graph. And 1 here, 1 empty, 1 included. So means 1 also included. So it's continue, continue, continue. Also, this is not included, but this is included. So it's included everywhere at the x value. Every value of x at here. When x equals to 1, this will be the value. The y is 2, right? Even though it's not here, but because of there is a value defined to this point, then there is continue. Okay, continue, continue, right? So it means that every value of x, there is a value of y. There is output. So it's from negative infinity up to infinity. How about range, right? Range, you look at you're taking a ruler, horizontal ruler, you're moving up. there is a graph, right? There is a graph. Here, there is a graph. So everywhere there is a graph. So during this side, even though here is empty, but there is a graph here, right? So there is a graph up to 3. So means negative infinity up to 3, but cannot include 3. Alright, so this will be the domain and range for this piecewise function. That's all for this. Then I will go for another example so that you more understand.